Hello everyone. In this video, we will be discussing about module 3, that is in design of machine elements module 3. Already in video 1, we had a discussion about what is bevel gear, definition, its types, advantages, disadvantages and applications. Then, before moving to the design as we discussed, we supposed to remember what are the terminologies what are the terminologies and its the formative number of teeth, its strength and other basic informations we need to study. So as a part of that one, so in this video we will be discussing a very important topic, that is the terms or the terminologies used in the bevel gears. So to understand the terms and the to understand the terms in the bevel gear, we need to try to understand the given sketch here. Let me explain this sketch. So this is actually a sectional view of two bevel gears which is meshed, and here you can able to see this the two gears. This is the gear 1 and this is gear 2, and you can able to see this is the angle. So already we discussed. So the theta s is the angle, and here we can able to see the example I have chosen is a meter gear, and it is since it is a right angle to each other, the two shafts. This is the shaft 1 and this is the shaft 2. Since both the shafts are intersected with an angle of 90 degree, you can able to see here. And we know what is theta p1 and what is theta p2. Theta p1 would be the angle exact like the center point between this 90 degree. So the angle with respect to the shaft 1 axis to the center point, to the referent axis, that is the theta p1, and for the shaft 2 it is theta p2. I think we are all very clear with what is theta is, theta p1 and theta p2, and we know like this is like an origin point, so 0 it is. Now moving to the next important terminologies, we have DO and DP. So and even it is applicable for this also. And here I'll be denoting this first gear as the pinion and second gear as the second a bevel gear as the gear, because to differentiate the gear 1 gear 2, I'll be calling this as the first one as the pinion and second one as the gear, and the outer diameter of the pinion I'll be denoting it as a DO, and the the mean diameter I'll be denoting it as for the pinion as a DP, P for the pinion. Similarly here for the what is that, for the gear where the outer diameter is a DO for the outer, and DG for the mean diameter for the gear, DG. And here you can able to see along with this with this outer diameter and the mean diameter, where some reference lines was formed, and based on that we have some points, that is with respect to the origin or with respect to the root cone, all those things. We have a pitch cone, we have a face cone, we have a root cone, and along with it we have a cone center, cone distance, back cone. So with we have many things including the clearance. So one by one we will discuss what is addendum, dedendum, everything we will discuss here. So first one is nothing but the pitch cone. So basically it is a cone containing the pitch elements of the teeth. So pitch cone, it is a cone which contains the pitch elements of the teeth. And what is cone center? Cone center is nothing but the apex of the pitch cone. You can able to see cone center, that is nothing but the start point. We can call it as the starting point. So apex is nothing but the starting point or ending point, anything we can call it. It is nothing but apex of the pitch cone, and it may be defined as that point where the axis of the two mating gears intersect at each other. That is with respect to this point, if the two axes if it get mates for two gears, the gears which intersect with each other, mean that point will be calling it as the cone center. Then what is pitch angle? Delta 1 and delta 2. Here we can able to see here delta 1 and delta 2. Here we can able to see it here. Here you can even show it as phi 1 and phi 2. Anything is fine with this. So pitch angle is nothing but the angle made by the pitch line with the axis of the shaft. Already in the previous types of gears, that is spur gear and helical gears, what we discussed, there also we have studied pitch angle, and it is denoted as delta 1 delta 2, or else need not be like delta, like we can go with the phi 1 and phi 2 also fine. And next very important terminology, that is the cone distance, which is nothing but the length of the pitch cone element. So cone distance I want to show you in the sketch. Cone distance, you can able to see the length of the pitch cone, we will be calling that as the cone distance. So the length of the pitch cone element is nothing but the cone distance, and it is also called as the pitch cone radius. So remember, cone distance can be also called as the pitch cone radius, because while solving the problem in like in different textbooks and even in different data handbooks, they may go with any of these words, like either the cone distance or the pitch cone radius, and it is denoted by OP. You can able to see this is O point origin and this is P point. So here also one cone distance will be there, and even the right side also one cone distance will be there, and even it is also called as the pitch cone radius. And what is the formula? Mathematically we can use to denote the cone distance means OP is equal to pitch radius divided by sine OP. So pitch radius is nothing but dP by 2 divided by, for the one first gear I'll be talking about, so sine OP1. So and similarly for the second gear means it is dG by 2, and for the sine OP2. For both the gears I could be able to define the cone distance. Then moving to the next one, addendum angle. So there is no change of definition. It is the angle subtended by the addendum of the tooth at the cone center. Here in instead of in previous we will be calling it as a normal gear when we discuss. Instead of the cone center we will be calling it as what is that the pitch circle we used to call, but here we are calling the addendum angle as the angle subtended by the addendum of the tooth at the cone center, and addendum angle is denoted as theta A for addendum, and mathematically addendum angle can be denoted as tan theta A equal to 2ha1 sine delta 1 divided by d1, and for the other gears 2ha2 sine delta 2 by d2. So already we know what is delta 1 and delta 2. Here we discussed that is nothing but the pitch angle. Then next one is nothing but dedendum angle. It is the angle subtended by the dedendum of the tooth at the cone center, and it is denoted by theta d. So mathematically tan theta d equal to 2hf1 sine delta t delta 1 by d1, and for the second gear it is 2hf2 sine delta 2 by d2, where ha1 and ha2 and hf1 and hf2 are the addendum of the pinion gear and dedendum of the pinion gear respectively. And face angle. It is the angle subtended by the face of the tooth at the cone center. The face angle is equal to the pitch angle plus addendum angle. Then root angle. It is the angle subtended by the root of the tooth at the cone center, and it is equal to the pitch angle minus dedendum angle. Then back cone, which is also called as the Norman cone. It is the imaginary cone perpendicular to the pitch cone at the center of the tooth. Crown height. It is the distance of the crown point C from the cone center O parallel to the axis of the gear. It is denoted by capital C. Mounting height. It is the distance of the back of the boss from the cone center, and it is denoted by small m. Pitch diameter. It is the diameter of the largest pitch circle. Then outside or addendum cone diameter. It is the maximum diameter of the teeth of the gear, and it is equal to the diameter of the blank from which the gear can be cut. So mathematically the outside diameter we can write dO1 and dO2, which is equal to d1 plus 2ha1 cos delta 1 and d2 plus 2ha2 into cos delta 2. And the proportions of the bevel gear, where the proportion of the bevel gear may be taken as, for the addendum it is 1, and for the dedendum it is 1.2, and for the clearance it is 0.2, and working depth 2, and the tooth thickness 1.5708. So this is the proportions of the bevel gear may be taken from the data handbook. So in case if you are getting the different values means even we can go with that one. So all this m indicates the module. So here if I am talking about a is equal to 1.0 module means based on the module value whatever getting, for example 3 4, based on that addendum value everything we can find it out. But the tooth thickness where we are not depending on the module value, only addendum, dedendum, clearance and working depth. For all these things where we will be depending on the module value. So again like in the design procedure we will be checking out by the trial and error method the correct module value. So with this I'll be winding up this video. Thank you.